We'll be going over how to assign R and S configuration to a chiral carbon. As we know, a chiral carbon is essentially when there's 4 different substituents attached to a carbon. So R1, R2, R3, and R4. When there's 4 different substituents attached to a carbon, we can assign something called stereochemistry. Stereochemistry essentially means one of these elements can be wedged, meaning it's in front of this carbon in space. Another one could be behind, and then these two would be on the side of the carbon in space. If you have a molecular model kit, this would be much easier to look at. So let's take a look at a real life example. Let's take a carbon that's attached to, let's say, an ethyl group, so CH2, CH3. A methyl group, let's do a hydrogen. Let's do a methyl group, and then let's do a random halogen, bromine. The first step in assigning priority is ranking importance. So ranking elements. This ranking is done based off the atomic number. Essentially, atomic number is basically based off the number of protons that exist in a nucleus, or you could just think of it as the bigger the atom is, the more importance it has. If we take a look at this, obviously bromine has the biggest atomic number, so this would be assigned priority number 1. Next, we have either this ethyl group or this methyl group. But if we take a look, these carbons are the same, but this carbon is attached to another carbon, whereas this is only attached to a hydrogen. Because of this, in this chain, if the first element is the same, the second element is the same, we would go for the third element, which would be this carbon. Obviously, carbon holds more importance than the third hydrogen that would exist here. So this would be assigned priority number 2, and this would be assigned priority number 3. Now, because our numbers go in a clockwise position, we would assign this priority R. So clockwise equals R, counterclockwise equals S. So this, in turn, would be priority R. Now let's change this up a little bit. Let's choose the same compound, but now let's make our let's make our CH3 group, the one in the back. Oops, my wedge is kind of ugly, I apologize. And let's do the hydrogen wedge in the CH3 group behind, or dashed. Now, if we assign priority again, this bromine would again be given 1, this ethyl would be 2, and this methyl would be 3. It looks like it's going clockwise, so we would be tempted to give it the R configuration. But one thing to note, our least prioritized element is wedged. Because it's wedged, we would reverse the configuration from R to S. So if lowest priority is wedged, change config. So this would now be considered an S configuration. Hope you guys enjoyed the video. Thank you.